Dhanasekar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We are seeing the compiler design subject. We are actually studying the LR parsers in the previous episodes. Already we have completed the SLR parsing table construction, which is generated with the help of the LR of 0 items. And then we have seen that there are few issues related with the LR of 0 items, that is in your SLR parsing table, because for some of the grammars, even though those grammars are there is unambiguous grammars and context free, which are meant for recognizing some kind of programming language constructs or so, we find that our SLR parsing table construction fails for some of the grammars. So now the question is how these kind of issues are rectified. So we should go for the new parsing technique with the help of LR, that is canonical LR parsing technique, and the canonical LR parser is the very much efficient parser, which will be possible to avoid the issues we faced with SLR parsing. So how we will be doing that is by introducing a over, that is look ahead, in addition with the LR of 0 items. So they are nothing but the terminals, which will be very much useful in deciding the reduce action. So in the SLR parsing technique, we compute the follow set to decide the reduce action, but whereas in the case of canonical LR parsing technique, that is in the LR of 1 items, we use the look aheads for deciding the parsing action rather than the follow set. So by introducing this look ahead into the canonical items, we get a new item of the form a derives alpha dot beta comma small a. The small a there exists exactly one, but we should not have two symbols together, that is concatenation, in the form of concatenation. So in that case it will be considered as LR of 2 items, but we are concerned only about LR of 1 items. So it should be only of the form a derives alpha dot beta comma small a, and this small a has no significance when beta is not equal to epsilon, and this small a, that is nothing but the look ahead, triggers the reduce action when beta is equal to epsilon. In that case the item is of the form a derives alpha dot. So that is how we will be using the LR of 1 items, and we have some functions for computing the LR of 1 items from the given grammar after making it into augmented grammar by introducing a production of the form s dash derives s. So the procedures being used for computing the LR of 1 items we had seen in the previous episode, where we had 3 functions. One is the items, which will give you the overall that is the entire list of canonical LR of 1 items, and there is another function called closure, that is given a set of items where we have items of the form a derives alpha dot b beta. So this b is a production getting expanded with the right hand side for that. So we will be having b derives dot gamma, and the look aheads will be computed from beta comma a by evaluating the first set of that. That is a closure. Then we have one function called goto function, which will be computing the transitions. So it accepts 2 arguments I and x, where I is a set of items and x is one grammar symbol. So if x immediately follows the dot available on LR of 1 item, then the dot will be moved on to the right position of that x, and then it will be returning the closure of that items, and sometimes it may be empty also, in that, which means that next to dot there won't be anything at all, or a terminal may be there. So, this is how we are computing the LR of 1 items. Now, having computed the LR of 1 items for the given grammar by converting it into the augmented grammar, the question is how we will be computing or generating the parsing table. Since we use LR of 1 items as the input, the parsing table is going to be called as the canonical LR parsing table, and the algorithm to be used for constructing the canonical LR parsing table, we have the algorithm which is very similar to the algorithm being used for SLR parsing table construction. And just because of there is a change in the input, that is SLR uses canonical LR of 0 items, and whereas the canonical LR parsing table parser, that is the CLR, which is using LR of 1 items. Because of the input is different, we have some modifications in the parsing table construction algorithm. So, here is the algorithm. We have the input, that is canonical set of items called C, which will be having some number of states, and within each state we will be having some number of items. And the output is going to be, we have the canonical LR parsing table which has 2 components, action and go to, and the action is defined for all the terminals, and the go to is defined for the various non-terminals. So, what is available for us is I0 to In, that is n plus 1 number of states are there, and each state has some set of items of the form a derives alpha dot beta comma small a. So, now how do we define the parsing action? So, there are 2 things. So, one is the how we are setting the action, and another one is how do we set go to. So, first let us see that is how we are setting the action component. If there is an item of the form a derives alpha dot small a comma beta comma b. So, what do you find here is just next to this dot we have a terminal called a small a. So, whenever we find an item of the form a derives alpha dot small a followed by beta comma b, which is an LR of 1 item with a terminal immediately following dot, it triggers for a shift action. That means, this a is to be shifted onto the stack for further processing action. We should know that is after shifting what is the state we have to land up, or what is the state from where we have to continue the rest of the parsing process. So, for that we should consult what is the output of go to of this II comma a, where II is the state in which the item of the form a derives alpha dot a beta is there, and a is the terminal which is immediately following dot, and assume that it goes for a state called ij. Now, the action component in your parsing table is going to be action of I comma small a is equal to shift j. So, this I is the state in which we have an item of the form a derives alpha dot for a beta comma b, and a is the terminal that immediately follows that dot, and this j is the state which will be the resulting state of the computation of go to of I comma a. Then the action is defined as action of I comma a is equal to shift j. So, that is about the shift action. So, now to look at the reduce action, we have an item of the form a derives alpha dot comma b. So, the important thing to listen here is dot which is on the rightmost end of the item. So, a derives alpha dot is there, and b, that is going to be the look ahead symbol. Now, this item is available in a state called I, then the action of I, that is a state in which we have the item of the form a derives alpha dot comma b, and small a is going to be the terminal, actually it is immediately following that. So, this is not small a, it is going to be the b, since it is the terminal which we are having. So, if it is a derives alpha dot comma b is in II, and then action of I comma small b is going to be reduce a derives alpha, that is your reduce action, and the third one is going to be the accept action. So, what do you do here is if s dash derives s dot comma dollar, which is a special item which we have introduced to convert the given context-free grammar into its equivalent augmented grammar. So, if s dash derives s dot comma dollar and it is available in the state called I, then immediately you can put that action of I comma dollar is equal to accept. As far as SLR parsing table is concerned, so here there is a difference. The action of I comma that is b is going to be reduced a derives alpha, where this b is obtained from the follow set of this capital A. So, there is a need for computing the follow set for all the variables available in the given grammar if we are concerned about constructing the SLR parsing table. But whereas in the case of the canonical LR parsing table, the information whatever we are getting from the follow set is filtered and we have the real set of items or input values for which the reduce is to be carried out will be available in the form of the look ahead items. So, we have if A derives alpha dot b, that is alpha dot comma b is in I, then strictly we should go for action of I comma b as reduce as far as CLR parsing table is concerned. And finally, it is going to be the reduce accept action, where we know that dollar is strictly going to be the follow symbol for every string at the end, because it is going to be the one which denotes the end of the string marker. So, every production which we will be having in the that is your augmented grammar will be terminated with the help of a dollar, and if dollar we find as the look ahead symbol, that is the input symbol which is denoting that nothing more is available in the buffer, then we should go for the accept action. And now we have the go to, that is how we are translating the generating the go to items. So, this is same as the one which we have done as far as even the that is SLR parsing is concerned. So, if go to of I comma a is equal to I j, that means from the ith state for the variable which is a, if you are getting the resulting state called I j, then the go to of that is I, that is the start state from where we are computing the transition, comma for which symbol we are computing the transition will be set to j, where j is considered as an integer there. We have seen that three actions are defined, one is going to be the shift action, and the second one is the reduce action, third one is the accept action, and also we have seen how we are filling the go to entries available in the go to component. So, what remains is there may be some cells which are yet not filled, and all those entries are that is equivalent to errors. It means if you are looking for an item, an entry which is not filled either by shift action or by reduce action or even by the accept action, so we are parsing a wrong input, it is the significant, that is a information which we need to understand from that. So, simply we can say that all those undefined entries are errors, and if we are finding that the parser is an error recovery parser or parser which can handle errors, then the errors will be marked with appropriate messages or with some error recovery strategies, so that when we are trying to access an error entry, appropriate error recovery strategy will be carried out. So, this is how we construct the parsing table from the LR of 1 items, which are of the form A derives alpha dot beta comma small a, where small a is the look ahead, which is exactly one look ahead at a time. Now, we can see an example. The table formed with the parsing action and go to is now called canonical LR of 1 parsing table, and the LR parsing is, this particular parser is called canonical LR parser, and if the parsing function has no multiply defined entries, then we will be calling the grammar as LR of 1 grammar. And another inference is we can find that there will be even there is more number of that is states when we compare with SLR. So, SLR if it is having some number of like 10 number of states, and canonical LR may have even 15 or more than that. So, that is showing the complexity of the parser, but one thing we should understand here is your canonical LR parser will not fail for any context free grammar in terms of the parsing table construction. So, which will be ensuring that it is completely reliable, that given a grammar definitely we will be able to come up with a parser for that. If you just ignore the complexity behind the construction of the parsing, it will be really advantageous for that. We will always get a parsing table for the given context free grammar. So, we shall go for a short break and then we will continue this lecture. Welcome back. We have seen that how we are constructing the canonical LR parsing table. What is the algorithm being used for constructing the canonical LR parsing table? And now let us see one example so that we will be able to understand how the parsing table will be constructed for canonical LR parsing table. So, first we have taken a grammar that is the familiar grammar S derives CC, C derives small c followed by capital C or D, and the very first step is just construct the augmented grammar. The augmented grammar is the one which is obtained by introducing an additional production called S dash derives S, and then we will be constructing the various LR of 1 items, and we start with S dash derives dot S comma dollar, where dollar is an item which is a terminal which will be denoting the end of the string. So, that is going to be the lookahead symbol to be introduced with the production which we have made as S dash derives dot S, and the output is going to be S dash derives dot S followed by dollar and return the closure of this item. The closure of this item is going to be S derives dot CC comma the first of beta A. Beta is epsilon, A is dollar, so concatenation dollar, and so we will be having dollar there, and capital C derives dot C followed by capital C, and here it is dot D. Because of this C gets expanded with two productions, C derives dot C capital C and C derives dot D. The outcome of your lookaheads will be the first of C dollar. First of C dollar is first of C, and first of C is C and D. So, you will be having C or D here. Similarly, C or D here. So, now we need to compute the various transitions for that. So, we are having the transition called which is the state called I1 obtained with the S dash derives S dot comma dollar, and I2 obtained with the S derives capital C dot capital C comma dollar from I0, and when this is expanded we will be having another two items with the beta is epsilon. So, we have dollar will be the lookahead, and I3 it is for small c, we move small dot right to small c, we expand this capital C, once again beta is epsilon and A is C or D. So, the output is going to be C or D here, and I4 it is C derives D dot comma C or D, because it is obtained from I0. We have I0 already, it is C derives dot D comma C or D. So, that is what the states up to I4, and we have more number of states also. So, here we have I5 has an item of the form S derives CC dot comma dollar, and I6 is having once again a new set of items C dot C comma dollar, dot C comma C capital C comma dollar, and dot D comma dollar. So, I7 is C derives D dot comma dollar, and I8 is C derives C capital C dot comma C or D. Then I9 is capital C is deriving small c followed by capital C dot comma dollar, and all the other the transitions are leading to the same stage. Stage means which we have already generated, that is one is going for I3, and I3 comma D goes for I4, and I6 comma D go for I7, and even I6 comma C is also going for that is I6. That means no need of generating those states as new states, because those states are already existing. We just add a transition to the already existing states. So, this is what the that is LR of 1 items obtained for the grammar. So, now we are going to see that is how we will be constructing the parsing table, that is the canonical LR parsing table. We have just seen how the parsing table is constructed with the help of an algorithm. The parsing table has two components, one is going to be the action component and another one is going to be the go to component, and we find that the action component and even the go to component are indexed by the state numbers. We have totally there are 10 states 0 to 9, and the first entry, that is we find that it is going to be shift item, that is shift. The rule what it says is, if it is going to be A derives alpha dot small a followed by beta comma some small a or b is derive is in the state called I, and if go to of that I comma small a goes for ij, then the action is going to be s followed by, that is shifting followed by j in the state I comma the input symbol, that is small a. That is action of, since we are having the item that is called we are having the item here, it is c derives dot c capital C comma crd, it is in the state called I0, and go to of 0 comma c goes for I3 and go to of 0 comma d goes for I4. So, action of 0 comma c is going to be S3 and action of 0 comma d is going to be S4. So, these two items will trigger for shift action. The first one says that action of 0 comma c is going for S3 and action of 0 comma d is going for S4. So, that is the reason why we have two shift actions S3 and S4. And when you look at the state number 2, this is going to be your state number 2. Once again, there are two items where next to dot we have terminals. So, we have, that is these two items are available in the state called 2. So, 2 comma c, where do we go? That is 2 comma c, the computer is transition the computer here. So, 2 comma c is going for S6 and 2 comma d is going for the state number I7, which triggers the action called shift 7. So, it is going to be both S6 and S7 will be the answer for the states from the states called 2. So, we have 2, it is S6 comma S7, and when you look at the third state, so the state number 3. So, we have the transitions from state number 3 for C giving you back to, that is 3, state number 3. It means that the action is going to be, action of 3 comma C is going to be S3 and action of 3 comma D is going to be S4. So, 3C is S3 and 3D is S4. So, we have 3C is S3 and 3D is going to be S4. And now we can look at what is happening in the state number 6. The state number 6 we have two transitions once again. 6 comma D goes for I7 and 6 comma small c goes for I6. So, we will be having S6 and S7 as the transitions. So, we have S6 and S7. So, that is all about the various shift actions. So, now we have to find out what is going to be the reduce action. So, we have that is around 7 number of reduce actions. The first one is available in the state called that is 4 for the symbol called C. So, what the reduce action says is, if an item of the form A derives alpha dot comma B, then in that state, whatever be the state, maybe the ith state, for the symbol B, you just say that it is going to be reduced by using the rule called A derives alpha. So, here we have 4 comma C is reduced by 3. So, 3 is going to be the production, it is going to state number 4. The state number 4 is this. We have a rule called C derives D dot comma C comma D. That is the fourth rule we are having in the list of productions in the augmented grammar. So, what should be done is, now that is in the state called 4, for the symbol C and for the symbol D, you reduce by using the production C derives D. Since C derives D is going to be the production called third production, so we will write it as R3, that is in the 4 comma C and 4 comma D we will write as R3, 4 comma C and 4 comma D we write it as R3. And when you look at the state number 5, so we have one more item here, that is S derives capital C dot followed by dollar. So, in the state number 5, for dollar we will put this as the first production to be used for reduced. So, we have that is R1 there. And when you are looking at state number 7, we have once again an item of the form C derives D dot comma dollar. So, 7 comma dollar, the action is going to be reduced with the help of C derives D, that is a third production. So, we will write it as reduced by 3 here. And looking at state number 8, we have one item, that is C derives C dot comma C and D. So, it is in the state number called I8. So, 8 comma small c and 8 comma small d, the action is going to be reduced by using the production called C derives small c followed by capital C as the production. So, since it is going to production number 2, so we have the rule called R2 and R2 here, and finally in the state number 9, so once again we have one reduction, that is I9 is having or obtained with the as a result of go to of I6 comma capital C. The reducing item, the resulting item is going to be C derives small c capital C dot comma dollar, and what is going to happen is reduce action in the state number 9 for the input symbol, that is dollar, that is the column number, and production is going to be the R2, that is second production available in the list of productions. So, you write it as 9 comma dollar is going to be R2. So, that is what the various reduce actions are described or specified in the parsing table. The only item which is remaining to be filled in the action component is accept. What the rule says is, if that is s dash derives s dot comma dollar is available in the state number I, then I comma dollar is going to be accept. We find that the s dash derives s dot comma dollar is in the state number 1. So, the action is this 1 comma this dollar is equal to accept. That is action of 1 comma dollar is going to be that is accept. So, we can find that 1 comma dollar is having the action called accept. So, that completes the action component, and go to we have another 4 number of items in the go to. So, they are actually computed for only the variables, and when you look at the variable items, so we have 0 comma s goes to 1. So, 0 s is 1, then 0 c is 2. So, those 2 are the items which are obtained as a result of the transitions for variables, and here remaining variables are here 2 comma c we have 5. So, we will write go to of 2 comma c is going to be 5, and go to of 3 comma c is going for 8, and go to of 6 comma c is going to be 9. So, these are the there is data values to be filled as far as the go to component are concerned. So, that completes the parsing table. So, we have generated all the that is entries, appropriate entries in the action component. It can be either a shift action or reduce action or even the accept action, and the remaining unfilled entries, as I told you earlier, when they are referred during the parsing action, the input is wrong. That is the meaning of the reference, and you can have some kind of routines being filled on those unfilled entries, that is the empty cells, which will trigger for some kind of error recovery actions. So, if the parser is that is having the provision for error recovery, it will go for calling the appropriate routines. So, now we shall see how we are making use of this parsing table for parsing a string. We shall take a very small that is example. The example here is CDD is the example which we have taken, and the parsing uses 2 data structures. One is the stack and the another one is the buffer. So, in the buffer we will be loading the there is the input which is supposed to be parsed, which is terminated by the special symbol called dollar, which denotes the end of the string, and the stack is initialized with 0, that is the state number where from the parsing is supposed to that is start. So, here we have the state called 0, and the input is CDD dollar. The first action is we see that 0 comma c, the action is going to be S3. So, shift C and resume from 3 comma d is shifting once again. So, shifting d, and then we will continue from 4, and 4 comma d is going to be dollar. So, it is initiating a that is a reduce action by C derives d. So, we know that when we are having C derives d as a production which is used for reduce action, you just compute the number of symbols on the right hand side. The number of symbols available on the right hand side is 1. So, we will be replacing or removing 2 number of symbols from the stack. So, D4 will be out, left hand side C will be pushed, and 3C will be consulted. 3C when you are consulting, we will be having 8 as an answer. Just push 8 onto the stack. So, if you continue like this, we will be having this end, there is 0 C to D7, reduce once again C derives D. It will be giving you 0 C 2 C 5, and now it is 5 comma dollar. The action is going to be reduced by using CC, Now there are two number of symbols available on the right hand side. We are popping 4 number of symbols, that is this 5, this C, this 2 and this C, having 0s and 0 comma s. In go to scenario we will be having 1, so 0 is 1 and dollar is on the input, so 1 comma dollar is going to be the accept action. So that is how now we can, since we have reached the accept action, we claim that the strings CDD is successfully parsed by the canonical LR parsing technique. So to summarize, we have seen the canonical LR parsing table construction and the algorithm for parsing table, and we have also seen that is how the parsing table is constructed and how parsing is done. To look at the problems, this is one problem which we find that for which we will not be able to successfully construct the SLR parsing table. Even though the grammar is unambiguous grammar, we fail to construct the SLR parsing table, but if you construct the canonical LR parsing table for this, we will really succeed because your canonical LR parser is more complex and it is reliable also. So that is about this particular episode. With this I conclude this episode. Thank you all.